Okay, I hope I won't disprove that in my talk now. So thanks, Kai. So one thing I did do in the right way today, I spelled OSGi with a lowercase I. That was pointed out yesterday in my talk that I could improve here. And another remark is there are two names on this slide. So one is myself, the other is Todor Boev. We are both architects at SoftwareAG. And Todor is very active in the expert groups in OSGi. He's not present today, but he's very much present in the thinking behind what I'm going to show and in the code that I will also show you. Yes, OSGi and Docker. So OSGi, as we know and love it, and Docker, as people love to use nowadays as their mechanism for creating runnable systems and deploying them. So to repeat from the invite to this presentation, we're going to present a tool chain which addresses specifically the questions around the modularity at the different levels of composing your runnable systems. And we think OSGi and Docker can come together quite well if you do it right, as we think. We think we have some insights, at least, not all of them, but some. And how to do this, especially at development time, while you're creating your systems, while you're growing them. There are some specific nice things about this, especially if you're using OSGi as your platform. You can update the system in significant ways without having to rebuild your whole container, and you, in general, can increase your productivity. So to illustrate this, I don't want to show too many slides. There are some slides, but mostly I want to show an actual system and an actual build for this system. So you'll be seeing a build which is quite close to production. So there's much more in this build than is of interest exactly today. So I hope I'll be doing the hand waving at the right points in time, where it's more about arbitrary choices that we've made in our build systems and the more interesting choices that are relevant for today's topic. So this is the kind of Hello World system that I want to show, which is trivial in the Hello World sense, but is not trivial in the sense that it really consists of various components that can run in different places. They do not have to, but they can. So the user has a very simple front end. That's just static HTML with a little JavaScript, but something running in the browser. And from that browser, there will be requests to the system in forms of service calls through REST from the JavaScript, very straightforward. And the browser is connected to a gateway, which is, in our case, an Nginx server, which routes the calls to the appropriate places in the system. It also serves up the static HTML. Then we have two services that the system needs to run. So we have a login service, which manages users, which again requires a component which is the database, a backend component. And the login service will know which users are registered, will authenticate them, and if required, will return a token. We use JWT tokens in this example to provide session information to the application to pass along to services so that they know they are talking to an authenticated user. And this service is sort of the Hello World part, where we have a service that can respond with hello username in this well-known fashion. And to sort of pick up on a topic that was mentioned in the talk before by David, we think the composition layers to use are important. So the lowest or the most basic layer is where you write most of your code, which are the bundles in our case, or modules in a more general term. So you implement them in the usual way. In OSGi, mostly, hopefully, just using declarative services, for example. You'll collect them in a repo. This could be local, this could be remote, but you can use them to provision. We collect then the bundles into larger components using features. So it does make a lot of sense to define higher level components within your wide space of bundles that you're using. So these collect bundles into meaningful functionality. I mean, last but not least, Eclipse itself will install features and not individual bundles. From these features, we build runtimes. These could be OSGi or non-OSGi, and these are provisioned from these components that we've defined through features. And these will be collected into container images. So you could already use the features to provision the runtime and run without any container model, but as it's quite popular and quite useful to use containers in many cases, this is the place where you would create the container images. Again, there would be either a local or there could be a remote repository. And from these images, you stand up your actual system that you want to run. So this would be the overview of the build. While I explain the build, I would just run it. So let me do this. So I'm going to build the whole system. And while it does that, I'll explain it here. So in the first step, so the whole build is Gradle-based. So that's just the way we do it at SoftwareAG. Again, there are many ways to orchestrate your build. We use Gradle. We use Gradle plugins for many different tasks in the build. The very first step is building the bundles, compiling them using BND to make them proper OSGi bundles. From these, and we store them in a sort of at least build time repository to share among components. We build P2 features as the next level of abstraction, sort of componentization, partitioning, if you will. We collect these in a repository. In our case, it's P2, so we use P2 for defining our features, which is not a very, you could even argue it's kind of historical choice because P2 was there, P2 is already used in Eclipse, so that was our mechanism to collect bundles into features. And from these features, we provision containers. So we have generic containers which form the basis, and we use the Docker capabilities of copying of layering containers to use a base container to which we add features and to have a runnable OSGi container. And these will again appear in your local Docker world, or could it be a remote Docker world as well. From these, we stand up the application, as you'll see in a minute. So I'll go to that point. So hopefully the build has run successfully. That looks good. So I'll go to, I'll go to my workbench to, let me close the editors I have, so to start from scratch. So here you see this project, which in some ways is quite complete. So it represents most that you would actually find in a production build. So it's quite close to production. You have the modules that I was mentioning, the bundles as the base layer. So here you have some that we're not interested in at the moment, but you would, for instance, have the actual greeter web service that I showed you that can respond with hello. You have services that can do this in different languages. So the actual greeter service is more like a manager service that can manage individual contributed services representing individual languages. We have further projects about the login and the user management. I'll not go into that. But for these modules, you will find in your workbench, in this case, specific projects. This is the master project, which in Eclipse terms doesn't even have a nature of any kind. Then from the modules, we build features. The features are more or less defined as a collection of modules. So here we would say, okay, what do we want to have in this greeter web service? It's just a few projects which produce bundles, so that's our feature. So there's no additional metadata associated with the features, just a deployment container. But it's very useful as such, because from this we can pick pieces to put into our containers. At the next level, we have the actual containers, and a container would usually have a Docker file. So here we can, for instance, for this web service, say it is based on the platform image, Docker image, and it would, the additional stuff that goes in there, we would define in our Gradle build file, where we would just say, okay, in this Docker container, it's already able to run the basic OSGi platform, but please put all these features in. And at this point, the feature granularity is the correct one to assemble what you would want in this specific container. So if we would look at the initial graphic, this container could represent the complete environment for running the greeter service. Perhaps it even makes sense to go back to this diagram. So here we would actually have one Docker image for this, one Docker image for the login service, one Docker image for the database that we just grabbed from Docker Hub, and one image containing our server plus this static content. So we would have 4 images in all that the build has created or just pulled from somewhere. And so now my next exercise would be to go to this configured system. Sorry, I think I should show it first. So we have the individual containers, and we now want to stand up the system. And the system more or less consists also of a Docker file, but this we're using the tool called Docker Compose. And this is a very efficient way to stand up groups of containers. So here you would collect the images that you want to refer to, and you can specify the mappings for the from the internal variables, configuration variables like ports used by each specific container to match sort of the overall configuration, so that the containers will find each other at runtime. So I'll stand up this system using Docker Compose. Oh, sorry, I could do one step before that. I could first go and just say, just show which images we have. Is it talking to me? Or is it trying to ask the internet? Because there must be kind of proof. Is it correctly configured here? No, it's not answering. Okay, so let's hope it will find. Let's do one more check, sorry. Docker machine. Okay, so it's running, so that should be okay. I'm using Docker machine because I'm on a Windows system. I don't have any native Linux here. I'm on Windows 7, not on Windows 10. That's why I'm using VirtualBox as the container, as the virtual machine holding the Docker images. So I hope I'm not in trouble here with the Docker images, but I'll nevertheless try to stand up my system. So let's go to Docker Compose and try to stand it up. So what this tool does is just picks the images that you've defined in your Docker Compose YAML file, and it will start up the containers, applying the configuration that is required. So here my application should be running. So let's try to go to this. I'm just wondering whether I should not be able to see these services. So there's something which irritates me because I should be able to use the Docker command to show the actual running containers. So this is my front end that I mentioned in the original graphic. So this is just static HTML, and it can use this. It has this way to ask the greeter service to give me a greeting. It's failing, but that's because I'm not logged in. So I will use a second service, and I will log on. login success, that's always good. And now if I go to this greeter service, I can pick from one of the languages offered here, and I could greet myself. So this is Bulgarian, Zdravejte, Udo, Zdravej Udo. So this is Todor's greeting, I would say, but there are also other languages available. So this would be the English greeting, the international one. Okay, so far so good. Now it's even managed to show me the Docker processes that are running. Can I look at the images? Don't know why it was waiting so long. Probably it was doing this 30-second timeout to find something on the internet. And I'm offline. Okay, so this kind of proves at least that I can build something which is not completely trivial. So it's not completely trivial because I have a selection of services implemented in OSGi. I used, for instance, JAX-RS to be able to remote them to talk over REST between the containers. And I'm able to use these 4 containers to run the system in a way which is quite close to what you would do with production. So the next more OSGi-like thing is that what I could do is I could run a test against this system. So I have something which is a plain unit test, which will test the system by creating a random user using random username and random user password. It will register this through the register API, the register service. It will try to log in using these credentials. It will try to get a greeting back with this with these credentials. So I'm going to run that as a user test, as a JUnit test, excuse me. Okay, it fails, which is usually a bad news, but in this case, I even understand what's going wrong. It's expecting a different greeting. So it has been able to run these services, and it's failing because I've changed the greeting text. So what I would probably have to do, I would have to go back to the code for that service. So this is just something built in the OSGi way, a declarative service. It's dynamic. I have this greeter manager service which will dynamically know which services have been registered against it in which languages, and it will simply call these based on the language I choose. And in this case, I have messed around with the with the actual message, so it breaks. So what I could now do, and this is something where this setup proves very useful, I can go and actually rebuild this bundle. So I would go to the modules and to the greeter language English. And simply, well, not simply, just tell it I'm offline and rebuild the jar. So there's a little bit of OSGi magic here, because at the end of the build, which is the traditional one, I just have a new bundle, we have a setup where I can where I have a little harness on the OSGi runtime which can accept an updated bundle and install it into the living runtime. So the bundle has actually been updated in the runtime without me having to do anything with the container and restarting nothing. And I should now be able to see this updated text because the services, when the bundle was reinstalled, the service went away. The greeter manager replaced it with the updated service when the new bundle was deployed and started. So I see this change, and now if I go back to my test, it should hopefully now run through. Okay. So that's already one quite significant thing. The change was trivial, I agree. The change was very trivial, but I could have provided a completely new bundle that, and as long as it's compatible with the deployed bundles in that specific runtime, as long as it can install and start, I'm fine. I can do these changes without having to do the complete cycle between editing, compile, build, deploy, restart the container. So this is quite nice. Another thing I can do is I can attach to the container. So let's see, where did we have the listing of the containers? I think here we have it. So here we have quite a few images. But let's look at the list of actual containers. I don't know why it's taking so long to come back. That's strange, but there you go. So this is the Greeter web service. That's the one we're inspecting more closely. So let's just ignore this one. Let's just do a Docker attach, which means, oops, sorry. So this will attach to a running container and will attach to the console if there is one in this container. And the way we set up the containers is that we have the OSGi console as the default stand-in, stand-out for this Docker image. So here we see that we're talking to the OSGi container, so we can look at the bundles, other way around, sorry. So we can look at the bundles installed here. We could look at the ones that have to do with our example here. So you see that we have the bundle providing the Greeter API. We have the 3 language-specific services. We have the actual service that manages the contributions. We have a test bundle here, and we have the web service, making it remotable. So what I, for instance, could do, I could simply go and stop one of the bundles here. I could stop bundle 25 is the one providing me with the English language. So if I now go back to our application, so if I call the Greeter service again, it will simply be missing this language. And I can use one of the others to greet, but I can't use English. And I could then go, here you see the console output provided by the bundle starting up. And the bundles also give some console output when the services are called. That's the usual logging we're seeing here. So if I start it again, I should be able now to see the full collection of languages. So let's close it and open the dialog again. So here we see English again, and we can go and use it in English. There is also one other nice little thing that is an extra that we've built into the platform. So we've implemented a way that you can run tests in the platform. So you can see here that we have something called a TestRunner. And the TestRunner is a little bundle that simply inspects the environment for JUnit compatible tests. And you can call it to list the tests that that it finds in this specific platform, and you could run them. So you could do some local testing on in your container. So it's also something nice you can do. You can, if you've configured it correctly, also directly connect a debug session to the container. So that's also nice. Let me see if I can get that running. So hopefully this is the right test. Yeah, so this would be a configuration where I am connecting to the debug port that has been exposed also through the Docker configuration. So I have to know the proper port, but then I can connect, and then I could do traditional debugging. So I could simply go here and run the service again, and if I've done everything right, I will be okay. I will be need to look to. Okay, I haven't added the right project, I think, to this configuration. That's why I need to add the right project to this one. So am I seeing the right one here? No, I'm not. I need this one here, I think. No, okay, so don't let me waste too much time fiddling here. I know that the reason is that I created the debug configuration, but in the debug configuration I probably mentioned the wrong project. But I think you get the idea. It's sort of live here. You can actually stop, start, and to kind of complete the capabilities that you have for development. You can also use the Eclipse hot deploy feature to deploy trivial changes directly into your runtime. So I could, the example I showed, changing the text in the hello service, I could have done that directly here and saved the file. It would have, through the debug interface, it would have hot deployed it. But that only applies to a very limited number of changes, as you know, because if you change anything about the APIs or the the interfaces, then that will break, and that's when you need what I showed you before, being able to run the actual build for the bundle and then remotely reinstall the bundle. Okay, so let me try to summarize again what we've seen. So we've seen that this edit, compile, run cycle is much more compact and much more powerful in this setup. Well, I think we've seen these different steps. There is a kind of inner and outer cycle. So if you do this, if you're in this inner cycle, you can make all these changes, updates, tests, and so on, work with your system, grow it without having to restart anything, without having to rebuild your images or containers or worry about them. Then there are cases where you will need to rebuild the containers, and then that's sort of the outer cycle where you do actually update the system. Still, I think this is quite developer friendly, because you're not having to go worry about multiple actual machines. You can do that all on your local developed machine, but the setup that you're working with is quite realistic and quite close to what you would actually use in production. So these are our findings, just to round this off. So we think that OSGi gives us additional power in selecting the right modularity at the right level. So you can, the way I code the system is really coding the logic. So I coded the greeter service, I coded the this login management of users. I did that all without worrying about containers, because if I worried already about what will the deployed system components be using, I will have a problem, because then I have to limit myself to the interfaces that a container provides. And here have a very coding and design-friendly way of really designing the components without worrying about the deployment and the container model. And then I have a certain flexibility in the middle layer by composing these into features that I use for provisioning the systems, the containers. And as I already mentioned, these containers that I've constructed are quite, well, in principle, I can use them for production. So I don't have to have an extra step to devise sort of production quality containers. And then the additional goodness that OSGi gives me is that I can do very much with the OSGi in the running system, because of the flexibility of being able to provision new stuff, to inspect the running system, to interact with it. There are these efficiency aspects. I can minimize the container footprint. We discussed the modularity of the JRE yesterday, so I could add this to using Docker images that contain minimal JREs built with JLink, and I have in all a quick turnaround. To use this familiar way of JUnit-like testing is also very powerful, because what I showed you first was actually a system test, but using JUnit and from the development perspective. Okay, there are some open ends, so you could argue about the limitations of the example itself. So, of course, the way the user management is done is very straightforward and simple, but still I think it's realistic enough to show the idea of how you would compose a more complex system. But it does also show that you can, once you have these containers, you can decide how to use them, how to use multiple instances of this container, multiple instances of that container, how to scale up, scale down, even partly while you're doing your development still. In the actual system I was showing, there's still too much configuration. We would like to have a more flexible way of, for instance, configuring ports in a central place, and other configuration information like the secrets that the various parts have to share to work with these user sessions. Okay, but that's the story for today. So I hope this made some sense to you. We think this is a good way to be sort of fully OSGi in the way we design the logic and the components, but also have a nice way to move these into the container world, which is just a different level of componentization. Okay, thank you. Questions? Okay, you ask for questions. Okay.